And welcome back. So in our previous segments, we've been talking about the physics of stars. And in particular, we talked about the ideal gas law, and then we also talked about nuclear physics. So now we're going to be applying those concepts and others to stars. So let's start by talking about some general properties of our star, the Sun. Its mass is going to be 300,000 times the mass of the Earth. It's going to have a radius of about 109 times the radius of the Earth. So that means that you could fit 109 Earths across the surface of the Sun. What is the Sun made of? So it's going to be made mainly of hydrogen and helium, with all of the other elements thrown in for good measure. But it's going to be mainly going to be 98% hydrogen and helium, 71% hydrogen and 27% helium. Okay, the temperature at the surface of the Sun. Now, what do we mean by the surface of the Sun? So don't look at the Sun, but if you were to look at the Sun, you'd see this yellow ball. And that yellow ball represents the surface of the Sun. So the temperature of that surface is about 6,000 Kelvin, and then we could convert that to degrees Celsius, and it turns out to be about 5,700 degrees Celsius, and then that turns out to be approximately 11,000 degrees Fahrenheit, just to give you an idea for what it's like. Okay, then inside of the Sun, the temperature is 15 million Kelvin. So it's much hotter on the inside because that's where all the nuclear explosions are going on. And next, let's talk about the luminosity. So remember that luminosity is the power output of something. So it's the amount of energy per second that it gives off. So our Sun gives off 400 billion 1 megaton nuclear bombs exploding. So the energy of 400 billion 1 megaton nuclear bombs exploding every second, and it's been doing that for the past 4.5 billion years. So that is a lot of energy output. And actually, our Sun turns out to be pretty bright. So there's only about 10% of the stars in our galaxy actually give off more energy than what the Sun does. But later, we're going to find out that some stars put out a lot more energy than what the Sun does every second. And then also, every second, the Sun converts about 700 million tons of hydrogen into 695 million tons of helium. So do you notice that some of the mass is missing? So what happened to the missing 5 million tons? Okay, it was turned into energy because we said that the missing mass goes into that formula, E equals mc squared, and then that's the energy output of a nuclear reaction. All right, so we're going to take a break here, and then when we come back, we're going to start to talk about the interior of the Sun.